Hello, my name is Aaron Green, and I will be demonstrating tutorial number 1 of the QA automation guide for Phoenix's QA automation system. Okay, let's just jump right into it. Step number 1 is logging into this test server directly or via remote desktop. And for this session, I will be accessing the server via remote desktop. And I already have a remote desktop connection set up here, so let's just remote right into it. You can see here auto service is currently not running, and I'm going to make it run here. You can make it run by either making it run from the link on the desktop, the shortcut, or you can go to the executable directly through computer, local disk, auto testing, auto service, and you can run the executable directly from here. Okay, so this is the auto service application here. The top window you don't need to worry about. That's for showing what is on the SQL server currently, which is access through the TMS web interface. But for debugging purposes, you don't have to worry about it. The second window on the bottom, you do have to worry about. That is the log message window, which is valuable for debugging, because it shows you the status of the commands being ran or the test script. And then the next little window on the bottom, the command box, is for running script commands directly. Okay, so step number 3 is to run the help command. And I just did. You can see all the available commands, script commands that are displayed, and you can run these commands manually directly from the command dialog box, which is right here. Okay, and then step number 4, we're going to list all the test scripts, and see these are all available test scripts that are in a test script folder, which can be found under C, auto testing, and then test scripts. So these are all the scripts under this folder. And then step number 5 is the first step that runs direct hardware commands. And I'm going to move this off the screen. And so the first command is to set the USB flash drive to the server, and to do that you just do set USB flash drive to server true. And you'll notice that when you type something, it auto-completes it, and once you see the possible autocomplete items, you just use the keyboard arrows to go to it, and then once you have it selected, just keep typing. And then so I want to do true. True means it will set it to the server. False means it will set it to the target platform. You can see here it already knows that the USB flash drive is set to the server. And now I'm going to set the save drive to the server as well. So again, you use true. False means to set it to the target platform. Okay, and now I'm going to apply platform power. False, which removes the platform power. So if the platform was off, it will now be, or I mean, if it was on, now it will be off. And then you can confirm that it is off by doing is platform power on. Again, it doesn't take any arguments, you just type it in, and you can see here that it is confirmed that the platform is indeed off. And now let's apply platform power using the apply platform power true command. And the platform isn't on yet. We have to press the power button. So let's go ahead and do that. press power button 1000, which is 1 second. So this simulates pressing the power button for 1 second. And now let's do the is platform power on command. And you can see here that the platform is now indeed on. Now let's go ahead and run the capture tool that shows us what's on the screen currently. And you can see here that it's at the EFI shell, and you can see the EFI shell text. So if we want to use the OCR software to get all the text that's currently on the screen, you just use the get text on screen command. And you can see here that the text that shows under the log window semi-resembles the text that's on the screen. And again, you can use regular expressions to match it correctly. So let's go ahead and simulate a key press. Hopefully it will do it. Okay, there you go. If it doesn't do it, try powering the keyboard off using the power keyboard false and then power keyboard true. So essentially that just resets the keyboard. And if you want to refer to a previous command, it's already there. You use the arrow keys when the box is selected, and you can just go through your previous commands and see like that. Let's simulate a key press enter for the next step, which is running a key string. Key string is just like key, except you can give it a whole string and it will simulate the key presses for you. So I'm going to do key string appear on screen. You can see that the text is now appearing on the screen. And then the last step on tutorial 1 is to turn off the platform, and we'll do that via press power button 5 seconds or 500 milliseconds. You can see the platform just turned off right away, and it's off. So that's tutorial number 1. Thank you. Hello, my name is Aaron Green, and I will be covering tutorial 1 of the QA automation guide for the Phoenix Test Automation System. Okay, so step number 1 is to map to the auto testing directory. So right now I'm remoted into the test server, and auto service is currently already running, but let's go to the auto testing directory. And then we'll create a directory called temp data. Temp data. Now here's a little tricky part. We want to copy the working BIOS binary to the directory was created, and I'm going to do that from my workstation to the network share that was on QA Auto 3. All test servers should have auto testing shared on a network. So I go to our temp directory and copy our working BIOS binary to that directory. And the name of it is Huron River X64.bin. So I just did that. And if I go to, and I just go to our server here and open temp data, you can see that I copied it to temp data. And then also we want to copy the script example to the script folder. So I access the network drive on QA Auto 3 and go to test scripts, and then I just copy copy, hold, and copy the post script to that folder. And step number 4, we just did. Now we want to open post.lua, the script we just ran or copied over. Go to my computer, auto testing, test scripts, and we will open with a text editor post.lua. Now you can either open scripts using Notepad or Notepad++. Notepad++ will highlight all the syntax, Lua syntax, which is rather helpful. So in step number 5, we're gonna replace the binary name with the binary that we just copied. So let's just copy the binary name this way. So we go to our folder, auto testing, and then temp data, the folder we created, and we just copy the name of the file, and then in quotes we put quotes, and then edit paste the name, and then we want to save the file. So these values here are for debugging purposes. These values are passed. When a script is called from TMS, these values are already passed to the test script. But in debugging, when running the scripts from autoservice manually, you will need to define these inside the script itself. Okay, so we just did step 5. And then in step 6, we want to run the test script manually. So we call a command, let me center this here, run test, and then post. And what this test script does is just a simple script to check if the system can post or not. And we'll just wait for it to run here. Right now it's setting the SATA and USB devices to the server, and because we don't want those devices to interfere with our test. And right now it's reflashing the board, so you can just turn it off and turn back on the reflashing device. Now it's reflashing the flash part, the BIOS flash part on the board, using the binary we gave it. With the binary that's in temp data. So right now it applied the platform power and it pressed the power button for 1 second. And now it's waiting 30 seconds for the system to post. And let's go ahead and run our video capture device. You can see here that it indeed booted to the EFI shell. And then the next section of code makes sure that FI shell is on the screen. And it caught that FI shell and removed platform power and said that the system did indeed post because FI shell was on the screen. So the rest of the document, I won't describe this right now, tells what each line of code does. I'll just give a brief description. So comments in Lua are done with a dash dash. The do file, this line here, includes helper scripts. In this test system, scripts can call scripts, and there's a lot of common functionality shared across scripts, and this is how we function out those scripts. So if there's something was changed in the system BIOS, you can just edit one helper script in it, it's passed on to all the test scripts, so you don't have to edit all the test scripts. This is and then here's the configuration settings unique to the test script. And then here's our debugging variables that we added for debugging purposes. Again, when you add a script to the TMS database to be ran through TMS, you would remove these 3 lines. Now, run test, this function here is not the beginning of the test script. Right down here at the bottom is the execute test command, which runs a function in common.lua. But your initial test commands for controlling hardware run at run test. So the idea is that execute test will call your run test function. And then these are just preparation commands here to set the server and turn off the platform. And then we reflash the board, we turn on the platform, and we wait 30 seconds. Again, you can see boot system delay 300 is right here. And you can see here is text on screen. If FI_shell is on screen, then it passes a test. Else, it will check if the current test case attempt is greater than the maximum test retry attempts. And if then it adds post fail, and else it returns false. So that's pretty much it. I provide a description of each line here. It probably will provide more detail than what I just stated. So I encourage you to look over the documentation. And that concludes tutorial number 2. Thank you.